Good morning, everybody, or good day, good evening, because we have about 50 people participating just now. We're expecting quite a few more to join. My name is John Dora. I'm very pleased to welcome you this morning, today, to this workshop seminar on climate resilience and design codes. Just a couple of housekeeping points. I don't know where you are, but certainly where I'm speaking from, we have no fire alarm tests this morning. I'm working from home, so that's good. And please keep your video links off, and please keep your microphones off. That's a couple of rules there. For any questions as we go through this morning and tomorrow morning, please put your questions in the chat to Sirma, and that can collate any questions that we can offer to the panel later on. I should have said, and I will say, that I'm the chairman of Project Team 1 under the Phase 2 extension contract under the European Commission's mandate M526, which is looking at factoring in future climate data and information into infrastructure and other design codes. So I've been helped a lot by the CIRMA project, Jose Matos and Sergio Fernandez, to put together this workshop, and of course NEN, the Netherlands standards body, with Abdeboek. So without much further ado, I've got a couple of agenda slides here. We're going to move into having an introduction and overview of the M526 work by Abdeboek and an overview of CMI by Jose Matos. Abdeboek,
yes,
is working at standards in Netherlands. He supports companies and government institutions in developing agreements and standards related to climate change, circular economy, and industrial safety. And he leads NEN's European activities in the field of adaptation. So, Ab, over to you.
Yes, thank you. I will try to share my screen. Is this visible?
Yes, you need to put it on presenter.
I need to put on presenter.
On the bottom line.
The bottom line, your screen sharing, new share. Sorry for this. So it's not visible now, I see?
It's visible, but we've got the editing view in PowerPoint.
The editing view, oh, okay.
You need the that's the one, that's the one. Excellent.
Okay, there we have it, okay. Sorry for this. So thank you all very much for the opportunity to exchange with you about the activities in the mandate 526, as it is named, and this is a core activity from the European Commission and from the European standardization organizations in relation to how to include adaptation to climate change into European standards for infrastructures. I would like to explain to you about the main elements of the work that is going on in this field and focus then specifically on the issue of linking future climate information into standards for infrastructures, the work of the project team number 1 that John was referring to. And we'll go ahead right now. So these are the issues that I would like to share with you. Well, I work at NEN. NEN is the organization that in the Netherlands facilitates the process of developing standards. There are standards on the national level, on the European level, and on the global level For today, the main focus is on the work towards European standards from CEN and CENELEC. NEN is working quite a long time on the issue of including the adaptation to climate change into standards. We do work at the European level and we work at the national level. You see here some of the activities at the European level and on the national level. And the key for today is the second bullet, the mandated project 526 to send CENELEC and the work in that framework. The objective of this project, in European terms, it's called a mandate, is to revise your infrastructure standards so that buildings and infrastructures across Europe are better resilient towards the adverse impacts of a changing climate, such as heat, extreme rainfall, drought, etc. It is looking at ways to revise standards for European infrastructures. Presently, we are working at 15 standards that are in the process of revision. We are also starting to develop standards or technical reports for adaptation measures, and the tailored guidance document has been developed. The work is coordinated by Dr. Andreas Walter, who will also present it today to you. One side step is that in the project we have developed a tailored guidance document, and it is tailored towards the writers of standards for infrastructures. So as clear as possible and in close connection to DCs working with infrastructures, we have developed this guideline, and we are more than happy to share it with other DCs on infrastructures and help you on a structured way to address climate change adaptation into standards. Then moving to the core of today, the project team number 1 is one of the 3 project teams working in this European mandate, and it has the objective to look how information about the future climate can be related and integrated into standards for infrastructures, and we focus especially on the Eurocodes. We have 3 activities in this group. The first step is a desk study. The desk study has been carried out, and I can report shortly about the main results. We have the workshop as a second step. That's today and tomorrow. And after the workshop, we want to channel insights from this workshop and other insights from our project team towards a technical report that provides guidance on how to use climate information in the Eurocodes and national annexes. And this work is carried out by quite an active group of dedicated people from science and from Eurocodes and from climate science, chaired by John Dora, our chairman of today's meeting as well. And you see the participants above on the slide. Then going shortly to the main results of the desk study. As I indicated, it has already been carried out. 55 standards have been reviewed, under which the structural Eurocodes, and the key of the activity was to look at what climate parameters are included in it in the present situation, so that you know what kind of climate information at present in standards is referred to, and it might be important in looking to the information that is needed about climate in the future. The work is carried out in a rather complex environment. I don't go too deep into detail for this slide, but you can see in the center that 4 DGs are involved in activities related to the issue of linking future climate information to European standards and the Eurocodes. Right above you see the work on climate science. On the left-hand side you see the work in our mandated work. And to the right hand below you see the work of TC250 and the Eurocodes. The desk study looked to existing standards for infrastructures and within the Eurocodes, but also other infrastructure standards. And I have here some examples of results. It will be a bit difficult to read, I expect, but this is the result for the standard on drain and sewer systems. You see that there is just a general description of that data are needed about rainfall intensity. Another example of what you see in standard is this one. This is related to equipment on airports, and it identifies that needed, that it states a threshold level of, for instance, 14 knots of a wind gust. So it does not specify you need this specific climate information, but it specifies a threshold value. And the third example is from the Eurocode, this one on snow loads. There you see that the key parameter is that data are in terms of a 1 in 50 year return periods and expressed in kilonewtons per square meter. So in the 55 standards explored, you see different expressions of needs for climate information. What you often observe in this study is that data refer to past information, and it's indicated some standards require the designers to source data themselves. Others specify climate thresholds, and finally there are standards that specify explicitly the parameters and the units. If you go to a bit more an eagle view, you can see that in this field there is a lot of initiatives going on, and it's quite a challenge to bring and to coordinate the activities together. I think this workshop is of great value in that process. As indicated, the next step will be going towards a technical report that structures guidance on what data is available and how to use that data in a reasonable way. And below you see some aspects that could be covered in that technical report. So that was about the outcomes of the desk study, which was carried out by John Dora. The second task of our project team is the workshop. That is bringing people together from the world of standards and from the world of construction science and the world of climate science, and looking how can we bridge between the knowledge that is developing fast and the world of standards, so that they take into consideration new insights. Then my last slide, the outline for the technical report. It will focus on what data will be available, ways to access the data, ways to deal with aspects as reliability and robustness, and how to align with the next generation of Eurocodes. I think today and tomorrow will be quite important to get more insight on what guidance is needed, what information is needed, how it is needed, and it will be of key value in developing this outline for a technical report. Thank you for this.
Thank you indeed, Ab. That was very clear and very comprehensive about what we're trying to do today and tomorrow and the longer term aim. I now would like to invite Jose Matos. Jose is a professor at University of Minho. He's chairman of the CIRMA project, about which you're going to hear in a minute or two. He's a president of Eurostruct and a vice president of IABSE. So he's also, like me, a civil engineer, so we speak the same language in some ways. And I must thank Jose and the CIRMA team, especially Sergio Fernandez, for helping us with the logistics of putting this together and the platform for this workshop. Thank you. Over to you, Jose.
Thank you, John. So good morning or good afternoon or good evening, depending where you are. I want to also acknowledge the team that was beneath the organization of all these workshop. And from my side, I'm going to speak now a bit as chairman of this project. This CIRMA project is an interregional Atlantic project that is entitled of Strengthening Infrastructure Risk Management in Atlantic Area. So most of transportation of people and goods in this area is made through rail and road infrastructures. And the performance of such infrastructure is affected by extreme natural events, as you might be aware, and also by strong corrosion processes, which result from the closeness to Atlantic Ocean. Of course, this happens in the Atlantic area, but it happens in all countries all over Europe. This project aims to develop a robust framework for management and mitigation of these risks by implementing measures at short, medium, and long term, and therefore increasing the resilience of such infrastructure. Can be transport, but we can also extend this to other type of infrastructure. It will also address the transportation infrastructures by developing a methodology for risk-based prevention and management. And this way, we want to also include a real-time process to monitor the condition of such infrastructure. It is very important in this project. As you can see, we have partners from all Atlantic countries, and we have industrial partners, we have academics and contractors, operators, and this is very relevant to mix them all and put them all speaking about this topic of the climate data and how should we integrate it on the management and on operation of the infrastructures. And this is the main base of this project. And this is the reason why for CIRMA it's very relevant to support and to do a push here for PT1. Also, I'm directly involved in PT1, but also I think for Europe and for everybody, this is very, very relevant. These are working packages that we have in CIRMA. As you can see here, we have 3 working packages, one dealing with climate change and natural hazards, another dealing with the instrumentation, and the last one with risk and resilience-based decision-making process. Then we have a test bed. I'm gonna be a bit fast because we are running already on the time, but these are the 3 general working packages, and I want only to put the faces here on the capitalization because it connects too much with the existing standardization and policy makers, and that's what we need to we want to that our outcomes from our project also be integrated in future standardization and standards and standardization bodies. In terms of the working package dealing with the climate change, the results will be an available database of climate change indicators that could be used in future by anyone for estimating vulnerability of transportation infrastructures, and also to increase the capacity to predict extreme events through the developed algorithms based on a given infrastructure asset location and climate change scenarios. On working package 5, we will develop a customizable climate-aware instrumentation, a guideline to allow infrastructure owners to deploy commercial monitoring with benchmarked performance, and also a novel software, portable and scalable climate-aware infrastructure monitoring for Atlantic area hazards. On working package 6, we will have as a result the forecasting of transportation infrastructure performance to multiple hazards in Atlantic area, comprising the likelihood of such events and their impact on infrastructures, and also a database with the most relevant risk mitigation measures, including their description, when they should be used, with what time frequency, their effects and costs. As a test bed, we have 2 test beds, one in Ireland, Northern Ireland, another one in Portugal, combining road and railway infrastructure. And the objective is to have a risk-based and resilience-based decision-making system for this kind of infrastructures that addresses the climate data and this previous working package information. If you want to get more information about CIRMA, you can visit us on the website or also on the Twitter account. So I wish you a fruitful and a very profitable workshop. And now it's time for our keynote speaker. Thank you, John.
Thank you, Jose. Thank you very much indeed. And now we move to the first of our 3 keynotes for today. We move to Dr. Andras Toth, who's a policy officer with the European Commission's Directorate General for Climate Action, DG Klima. And Andras deals with adaptation to climate change in a number of policy areas, including standardization. And his background is much in sustainability and in the kind of area that leads to understanding adaptation and the importance of standards. So Andras, if you share your screen and deliver your keynote. And we're very grateful to have you here, Andras. I think you're a good friend to standards. Thank you.
Thank you very much, Joan. Can you hear me well?
Yes. Thank you.
Good, excellent. And you also see the presentation which I launched? Good, okay, so we can go. So I work in
I suggest, sorry to interrupt, can I suggest that you move the participants or the camera, because there are some areas on the slide that we do not see because of that. Thank you.
I didn't realize you also saw the this little box of, yeah, okay. So is it better now? I guess it's better. Now what happened to the screen? Am I still sharing the screen? Because now it disappeared for me.
Now it is not sharing.
No, I don't know what happened. Screen sharing is still, the host disabled participants screen sharing. That seems to be some problem, not on my side then.
Just a moment, I'm trying to solve this.
I mean, let me know when I should start sharing the screen again. Maybe in the meantime, I can explain what I intended to explain on the cover slide, is that I work in.
You can share the screen, please.
Okay. So, yep. Okay, can you see the slides now well?
Yes.
Yes.
Okay, so yeah, so I work in the adaptation unit of the Directorate General for Climate Action of the European Commission, and I will tell you about the new EU strategy on adaptation, which was recently adopted, and its relationship to standardization. The background to our work on climate change adaptation is obviously the changes that we are observing in climate, which have now far-reaching effects, not only inside but outside of the European Union, and also in every European region. This ranges from unprecedented forest fires in the Arctic to increasingly devastating droughts in the Mediterranean, from accelerating erosion on the Atlantic coast to forests in Central and Eastern Europe that are decimated by new pests. So this scenario is not going to improve anytime soon, because even in a best case scenario of mitigating climate climate change gas emissions, these impacts are already baked in the Earth system and will be with us for a number of decades. So this is the reason why we have chosen to, not only us, but also a number of policymakers around the world have started to focus on climate adaptation. Beyond the natural environment context, the policy context behind this is also quite robust. So we have the 2030 Agenda for Sustainable Development with all these sustainable development goals that are affected by climate change. So there is a goal on climate change itself, but a number of other goals such as water are affected by climate change impacts. There is obviously the Paris Agreement, which focuses on mitigation and adaptation equally. And more recently, there is from the end of 2019, there is the European Green Deal, under which there are a multitude of Commission initiatives or proposals for laws which have an adaptation component or have important adaptation aspects. I will list here a number of them. Maybe I would highlight the European Climate Law and the European Climate Pact as horizontal instruments which have a strong adaptation component. For the rest, I will probably come back to them during the presentation. So this EU strategy on climate adaptation that we just adopted is not without precedent, because the first EU strategy on adaptation dates from 2013, and we started to evaluate that first strategy in 2017, culminating in the publication of the evaluation in 2018. And that evaluation showed that there are a number of areas in which the strategy might need to become stronger. So we started an open public consultation, gathering a large number of responses over a blueprint that we developed at the time, accompanied by expert reviews and the usual impact assessment that the Commission develops for its initiatives. And all this culminated in the drafting and then the adoption of this new EU strategy on adaptation to climate change on the 24th of February 2021. Another process to highlight here is the climate law, which is still under discussion in Parliament and Council, but it very much looks like that it will actually make it mandatory for member states to develop adaptation strategies and to strengthen resilience. So the main complementarity between these two initiatives is that the strategy has no obligations on the member states, whereas the climate law by nature is going to impose member states some obligations also in relation to adaptation. So now going into the details of the strategy, there is an overarching vision, which is that by 2050, the EU should be a climate resilient society, fully adapted to the unavoidable impacts of climate change, which is an ambitious goal, but that's why we have set it so that it provides a strong motivation for the different actions under the strategy. So the objectives we have is smarter adaptation, so more systemic adaptation, faster adaptation, and stepping up international action. So you will notice, for instance, for this last bit, the international action, that it was not part of the previous strategy. That was one of the areas in which we felt that the strategy needed an update. I will go now into the details of the different objectives and spend a bit more time on the one which is the most relevant for standardization. So as far as smarter adaptation is concerned, this is about improving knowledge and managing uncertainty. So obviously it will involve a lot of research on pushing the frontiers of knowledge on adaptation. We want to improve the risk and losses data related to climate that is available to the different stakeholders and to the Commission. And the already existing Climate Adapt platform should be further developed to become the authoritative European platform for adaptation knowledge. As for the more systemic adaptation part, this is basically targeting the governance of adaptation. So we will work with the member states to further improve their adaptation strategies and plans. We would like to address all levels, including the local ones. We would like to address even individuals. The climate pact will be possibly a good tool for that. And we would also like to make sure that across all the categories, all the social classes that exist in Europe, we are ensuring that a just resilience is developed against climate change impacts. We also intend to take the concept of climate resilience into the higher level of macro fiscal policy. So we have now successfully started a collaboration with other Commission departments who so far haven't paid that much attention to climate adaptation, such as the Economic and Financial Director General of the Commission, who are now looking at the budgetary issues within the member states. So it is now being assessed what kind of risk the climate holds in store for the budgetary stability in the different countries. When it comes to systemic adaptation, one concept that we would like to promote very much is nature-based solutions to the extent possible, because we cannot treat adaptation in isolation from the state of nature, which is also deteriorating. And from experience, we see that those solutions that involve nature-based solutions are also helping other goals such as biodiversity to prosper. I'm intentionally skipping the third one, third objective, which was faster adaptation, because I will spend some more time on it. So the stepping up on international action will be basically increasing support for international climate resilience and preparedness, scaling up international finance to build climate resilience, and to strengthen global engagement and exchanges on adaptation. So this is an area in which we have had some activities in the past, but they were not based on the strategy. And I think the Paris Agreement's adaptation component now provides a strong motivation for the EU to step up its action on the international stage. Now coming to the faster adaptation, this is where all the infrastructure-related issues are and physical assets related issues are tackled. So first of all, we would like to accelerate the rollout of adaptation solutions, which means basically providing the financial resources that are necessary to implement these solutions. So we will be working under the next multi-annual financial framework, but also the recovery and resilience funds to make sure that the adaptation projects are implemented in the member states. But we're also talking about the sustainable finance, innovative financial solutions, and providing the sustainable finance taxonomy, which will have a climate adaptation objective in its implementation, and will help identify when a particular project or economic activity has a significant harm in terms of climate adaptation, or when it is substantially contributing to it. Reducing climate-related risk will be ensured, first of all, through an updated climate proofing guideline for infrastructure projects, which is in the final stages of drafting within the Commission services, and is going to be published in time, so that now it will be deployed to a wider range of projects, not just the major projects as in the past, and it will also be updated with regard to its content. And this is where the standardization related activities will also take place. I'm going to spend a bit more time on that, obviously. We are also going to work with the insurance companies a bit more than before. This was already part of the previous strategy, but now we are really going to step up action with them through a climate resilience forum, in which we are going to look at how the insurance sector can share possibly its risk or damage data, and also to see how they can make use of, for example, synergies with the sustainable finance taxonomy to identify which are those assets which are well protected from climate impacts in the future. So there's a lot that can happen in that sphere. And also we need to water is a key component in the climate system. It is one of the priority areas that are being affected by climate change. So we are also planning a number of activities to increase the climate resilience of the water system in Europe, primarily through the existing water legislation, but also maybe interesting for the standardization communities. We are also looking at legislation on products that use water, like washing machines or dishwashers, and trying to reduce their water consumption in the future is a small but important contribution through the households to the water saving that will become necessary in the future. Now, coming back to the standardization, because this is the topic of the workshop today, I will mention how the standardization is tackled in this short communication. First of all, obviously, we recall the good work that has been done by the Adaptation to Climate Change Coordination Group, following up to the mandate 526 in 2014, which was already included in the previous strategy, the 2013 adaptation strategy. So the dozen priority infrastructure standards are now actually more like 15 standards, which are being revised to take climate change into account. As to the future, the strategy foresees that we will increase cooperation with the standardization organizations to climate-proof a wider range of standards. So we are going to look beyond infrastructure standards, looking at other sectors as well. We would like to also help speed up the development of new standards for climate adaptation solutions. So not just look at how standards on infrastructure are prepared for taking into account the future changes in climate, but also how those assets or tools that are meant to help adapt to the new climate could be standardized for better promotion and rollout across Europe. Lastly, this is quite a new item, but we realized that much of the standardization activities that are relevant to climate change are actually happening at national level, in national standards, when it comes to building codes, for example. So we would like to encourage the member states to talk to their national standardization organizations and see how those can assist them in the implementation of the national adaptation strategies. And all this should be done, obviously, in complementarity with the EU level standardization work. So how will this standardization work in the future? How will it materialize? We are probably going to look at a new mandate to the standardization organizations, because the work under the current one is possibly going to finish by next year. And so we will, in some form, communicate our wishes to the standardization organizations as to how to go on with the work. For the planning for the next steps under the strategy, some of these have already happened. It's just to show that we are now talking to the higher levels. So we have good contacts with the Portuguese presidency, who will put the strategy on the agenda of the Environment Council in several instances, they plan to have conclusions on the adaptation strategy by June. We are also doing a rollout campaign through the member states. We plan to visit each member state by the end of the year and talk to the authorities to see how they plan to implement, ramp up implementation of the adaptation strategies. And we are also looking at concrete deliverables already this year. And the very first one, just to show that we mean business, is that the European Climate and Health Observatory was set up already on 4th of March. Further deliverables are expected this year, including this possible mandate on standardization to the standardization organizations. So with this, I would like to thank you for your attention, and I wish you a good discussion today in the workshop, and I'm happy to answer any questions. I think we don't have a question time now, but it will be by email, but please feel free to ask. Thank you.
Thank you very much, Andras. It's great to have that perspective from the top, looking at some of the themes there, including the urgency of having standards able to foster adaptation because of the way the climate is changing rapidly. Thank you very much for that. We now move to Dr. Andreas Walter, who has studied statistical climatology at the University of Frankfurt in Germany. Andreas is in Deutsche Wetterdienst, the National Meteorological Service of Germany, and he works in climate change consulting. He has been a member of the working group for the very first international standard on adaptation to climate change, which was ISO 14090. And that was the standard I had the privilege to be the convener of the working group, and also 14091, which has just been published on impact, risk and vulnerability. Andreas also is the chair of the Adaptation to Climate Change Coordination Group at CEN, which Andras just mentioned. And Andreas is going to give us a keynote from his perspective from a meteorological point of view just now. Thank you, Andreas. Over to you.
Okay, thank you. So I'm going to share my screen. Can you see this?
Yeah.
Okay, thank you. So thank you, John, for the kind introduction. And I want to share some thoughts on factoring climate data into infrastructure standards for a resilient future. And we might deal with other threats right now, but climate change doesn't stop existing. It's just waiting behind the corner, and it will hit us sooner or later with full force. It's just not the top event right now. We have other things to consider, but sooner or later, we will experience the impacts of climate change. So starting with a perspective, with a European perspective, as Andras already mentioned, the EU strategy on adaptation to climate change acknowledges that Europe is facing a series of severe impacts that will affect livelihoods, ecosystems, and economies. And despite various efforts already undertaken at various levels, there is still considerable need for immediate action. And the key word here is immediate action. So in the EU strategy, there are some requested standardization activities. For example, to develop tools, especially guidance, that will ensure the adaptation to climate change can be taken into account in a systematic way in European standardization. Second, to identify existing European standards and European standardization deliverables, including those under development that are most relevant for adaptation to climate change. This means to identify and work on standards whose subject is most vulnerable to climate change. And further, to revise identified European standards and to draft new ones with a view to enhancing the resilience to climate change. So since this, the activities carried out by the Adaptation to Climate Change Coordination Group, which I am the chair of, are linking standards to infrastructure, to future climate conditions, scaling adaptation measures to the European level, adaptation of climate change adaptation and other standards for infrastructure. And the Adaptation to Climate Change Coordination Group will mainly focus on 3 priority areas which are identified in the EU strategy on adaptation. And these priority areas are transport infrastructure, energy infrastructure, and building, respectively, constructions. And in all those activities, the use of climate data, especially in these standards, is vital. And I want to share now some thoughts on climate data, about observations, about future conditions, climate projections, just to give you insight on what we're dealing with here. So first of all, climate change is already observable in meteorologic variables. You see here on the top level, distribution of mean temperatures for the months April, September. So mainly the summer months, in this case for Germany. And on top is the distribution for the time span 1881 to 1990. And as you can see, we have an outlier or a very extreme event, which is to the far right. It's 1947, which was, at least in Germany, a really hot summer. And the coldest summer temperatures are to the left on top, is 1902. So you see the distribution there, the mean value, and on the bottom level, you see the same distribution as in top, but additionally, you see the distribution of mean summer temperatures for the time period 1991 to 2020. So what you can see here is that we observe a shift in the mean temperature of roughly 1.5 degrees Celsius already compared to the reference period. But additionally, we see a broadening of the variability, which means there's a likelihood of occurrence of extreme events, which will become more frequent. You can see to the far right, for example, the year 2018 in Germany, which is way beyond the temperatures we observed during the earlier period. And the year 1947, which was an outlier in the older period, becomes a year, this is mainly now a normal summer year for Germany. So this means that mean values and variability are already changing, as we can observe in, for example, here, temperature. So considering future potential scenarios, the emissions of greenhouse gases are essential. So what you can see here are 4 different scenarios used in the latest IPCC report. We have the RCP26 scenario, the blue one on the bottom. It's more or less a climate protection scenario. And with this scenario, we will end by a change in global temperature at the end of the century of about 1.7 degrees Celsius. So this scenario is the only scenario with which we can achieve the 2-degree warming goal from the Paris Agreement, and necessary are also negative emissions. This means to get greenhouse gases out of the atmosphere actively. On the top of this chart here, you see the scenario 8.5, which is more or less a business as usual scenario with no significant climate projections, climate protection implemented. And if we follow this emission path, we will end up at a global warming of 4.7 degrees Celsius at the end of the century. And I have to mention here that currently the GHG emissions on the global scale are well above this 8.5 scenario, so that we might get a warming which is a little bit more than 4.7 degrees Celsius global warming at the end of the century compared to pre-industrial times. if you have to choose a scenario, I just want to share some thoughts on climate projections. What you see here is on the right, some climate projections for till the end of the century, till 2100. And under different scenarios. In blue is the projection carried out by the RCP 2.6 scenario. Green is a moderate scenario, the RCP 4.5. And the red one is the RCP 8.5 projection till the end of the century. There is a slight range. The solid line is the mean value of the distribution of the model ensemble that we use. We have to use a model ensemble because there is no and will be no single best model. So you have to rely on a variety of models which give you a likely range of a temperature change in this case, and not only on one model. So the use of model ensembles for each scenario is essential, and uncertainties are unavoidable. We don't get a single value which gives you a projected change for the future, but we get a range of a projected change for the future. And adaptation measures and standard writers have to deal with this uncertainty and implement climate change in their standards despite this uncertainty. As the mean changes, also extreme events change in the future. What you see here is an example of extreme events. It's high percentiles of the distribution of summer maximum temperatures in this case, for example, but it's valid for other variables like rainfall, for example. You can see from left to right the 90th, 95th, 99th, and 99.9th percentile of the distribution of maximum temperatures in summer. And if you look to the right lines, you can see on bottom return time, and the return time of the highest percentile in this distribution was in the 50s. 10 years. So every 10 years, we saw an extreme event, which was way above the normal expected distribution. And if you follow now the lines from bottom to top, especially the red line for the RCP 8.5, you can see that at the end of the century, an event which was likely to be observed every 10 years will become an event which is likely to be observed 4 times a year. This is clearly a hint that extreme events are changing, in this case for maximum temperature, but as I already mentioned, it's also detectable in rainfall data and so on. So it's likely that an event will become more frequent. And in this case, what is also to see is that the frequency of extreme events increases over proportional compared to not so extreme events. So already coming to my last slide, to conclude, there is a lot of historical, recent and future climatic data and indices available, which can be used for implementation in standards. Climate model outcome is unavoidable, uncertain due to the emission scenarios you have to select. Due to the ensemble members, you have to select for your climate model ensemble. And due to internal parameterizations in climate models themselves, adaptation measures must be implemented even under conditions of uncertainty. That's more or less the main point here, that you have to consider climate change even under conditions of uncertainty in standards. But the good news is that uncertainties can be quantified using statistical measures, for example, percentiles in the distribution of the climate model outcome. And these percentiles give then a likely range of change or a climatic stress, which can be quantified and used further in standards adaptation. And yeah, it's unavoidable to use this range for scaling of adaptation measures, because as I already said, there will be no single precise model in the near future. And the data you need to implement in your standards is available from National Hydrological or Meteorological Service or from the Copernicus data store. But what is most important in my view is that you act now. We don't have time to wait any further because, as I showed you in some slides, the climate is already changing, and we get more and more extreme events with a higher frequency and potentially also with a higher intensity. So that's all from me. And as you can have a look at the European warming stripes, which you're probably familiar with already, I want to welcome you to this workshop from my side as well, and wish you a fruitful workshop, and thank you for your attention.
Andreas, that was wonderful. Thank you very much. Some thought-provoking points and facts there from Andreas Wouter from DWD. Thank you. Now our next keynote is Dr. Steve Denton. Steve is WSP's head of civil, bridge and ground engineering, leading a 650 staff as a unit. He's a visiting professor at the University of Bath, chair of the international committee responsible for the structural Eurocodes, TC250, CEN TC250. He's a fellow of the Royal Academy of Engineering, and he combines his leadership roles with a high degree of involvement in technically complex and major projects. Steve, over to you to bring it into the standards arena. Thank you.
John, thank you very much. Can you hear me okay?
Yes, perfectly. Thank you.
Great. And is my screen displaying?
Yes, perfectly as well. Thank you.
Excellent. Great. Thank you very much. And thank you very much for the invitation to come and speak this morning. So as John said, I'm going to talk this morning around the evolution of the second generation of the Eurocodes and share with you our plans for addressing climate change within them, specifically in relation to environmental actions. I thought it might be helpful just to start off with a few facts and figures relating to the Eurocodes, because I'm conscious that we have some people participating in this workshop who come from the standardization realm, but others from climate science and other sectors. So when I talk about the Eurocodes, what I'm talking about are the design standards EN 1990 through to EN 1999. And these are the documents that are used for all structural and geotechnical design in the built environment and infrastructure sectors, as well as more broadly across Europe and in many other countries around the world. Just in terms of a few facts and figures, so when the Eurocodes were first implemented, the European Commission undertook an impact study, and this was back 2007, 2008, and determined that they were a suite of standards that would be used by somewhere in excess of 500,000 engineers. So the impact is really profound of these documents. There are currently 10 standards in 59 parts. They run collectively to a total of around 5,000 pages. They contain within them just over 1,000 parameters that are open to national determination. And I'll come back and talk about that later, because that's important in the context of what we're talking about in this workshop. They are documents developed by consensus across 34 countries that are members of CEN. And as you can imagine, for a suite of standards of this scale and importance, within TC250, which is the CEN committee with responsibility for the Eurocodes and the committee that I chair, we have quite a complex structure of subcommittees and subordinate groups that actually totals 97 subcommittees, working groups, active task groups. And there's probably somewhere around 1,500 or 2,000 experts involved at a European level in Eurocode activities. And given the scale of involvement in mirror committees in countries, probably 10 times that actively involved across Europe at the moment. So you can see from that this is a fairly sizable organization working on a very important suite of standards. The Eurocodes, the first generation of the Eurocodes, as I'll come onto in a minute, were implemented across Europe around 2010. And in recent years, we have been working on the evolution of the second generation of these standards. And I want to talk to you about that this morning because part of the mandate that's already been mentioned by AB for the evolution of the Eurocodes, mandate M515, invited us to consider the implications of climate change and to embrace that within the evolution of the standards. So we received the mandate from the Commission back in 2012. We responded with technical proposals in 2013, and again, I'll come on and talk around sort of current status and how the work is evolving. But perhaps to say that what we are working on with the evolution of the structural Eurocodes is one of the largest standardization programs, certainly the largest by Commission funding in European history, one of the largest international programs of evolution of standards ever. So it's a major program of work. It's being undertaken in 4 overlapping phases, around 76 project teams established to undertake different elements of the work. As I've mentioned, a complex structure of subcommittees and working groups and task groups that then oversee that work and help us navigate a path towards achieving consensus across the 34 countries. And to get a feel for the timeline, and again, that's important for what I'm going to be talking to you about this morning. The first phase of activity, as you can see from this diagram, started in 2015, first formal phase of activity. And concluded in 2018. The second phase started in 2017, finished last year, and the third and fourth phases started in 2018, and those project teams are concluding this year. And what happens is that once those project teams have done their work, then their deliverables are passed to the relevant subcommittee, who then navigate the various CEN requirements in terms of inquiries and formal votes. What this means is that the work on the second generation of the Eurocodes will lead to the delivery of a complete new set of Eurocodes. The first standards developed under M515, actually the first documents being technical specifications in certain areas, became available to national standards bodies in 2020. And we're going to be working through a very intensive period of activity, of inquiries and formal votes, leading through to our final date, target date for formal votes on the new Eurocodes will be October 2025, meaning that in early 2026, the last of the new Eurocode drafts should be made available to national standards bodies. And then obviously there needs to be a period during which national annexes, as I'll talk about in a minute, and other implementation activities are undertaken, meaning that we have set a date of agreed across all the Eurocodes, a date of March 2028 as the date for withdrawal of the last possible date for withdrawal of the Generation 1 standards. And what I would say is that the way in which we have designed this, there is opportunity for countries to move across earlier if they wish to. but that March 2028 date is the backstop date, the last possible date in accordance with CEN rules, when countries can cut across from the Generation 1 standards to the Generation 2 standards. So I wanted to explain within the structure of the Eurocodes the important role of national annexes. And for some of you, this will be very familiar, but again, it has important implications for the subject of this workshop. Under the regulatory frameworks within which the Eurocodes are implemented, there are matters which need to be left open to national determination, principally matters of safety, but there are other matters that need to be left open to national determination. And the way in which that is handled for the Eurocodes is that we include within the standards what we term nationally determined parameters. These are clearly identified, clearly defined parameters, and we provide for them, generally we provide a default value or recommended value, but we leave it open to countries to choose the values that they wish to use within a country, and that they need to specify those values within what's termed a national annex. And you can imagine that environmental actions, principally snow, wind, and thermal actions, are clearly something which is geographically dependent, and therefore it is natural that those parameters are nationally determined parameters, and actually the values for the basic thermal, wind, and snow loads or actions are included within national annexes. So that here I've just shown some extracts from the UK national annexes, which show the respective maps for snow, wind, and thermal, which in this case minimum. Of course, there's a companion diagram for maximum temperatures. And as Gab already noted, these are based on an annual probability of exceedance of 0.02. So these are contained within national annexes and are left open to the countries and national standards bodies, the CEN members, to include these within their national annexes. So that establishes the overall framework and the timescales for the second generation of the Eurocodes implementation. What I wanted to do now is to move on and talk specifically about how we're looking to consider climate change within the second generation of the Eurocodes. And the consideration of climate change was an explicit requirement of our mandate M515. We initiated a team right at the start of the program of work to look into this. And it's clearly a complex area. And what we need within the Eurocode suite is, if you like, a reasonable way in which the effects of climate change and the effects of climate change, principally on environmental actions, can be handled, which addresses the important issues that we're concerned about in this workshop, but also importantly aligns with one of our overarching objectives for the evolution of the Eurocodes, which is to enhance ease of use and to make sure that the application of the standards doesn't demand a disproportionate level of effort. So we've been looking to find the right position in relation to that, and if you like, provide a bridge between the climate science and climate change concerns and the practical activities of designers of structures, building structures, and civil engineering works. And where we have landed or are landing is some new text, which still needs to go through the inquiry and formal vote processes, but which has so far received a favourable response from CEN members. And what I've got on the screen here is the draft text that we're working with at the moment here, extracting the relevant text relating to wind. So what you'll see here is that in terms of that fundamental basic wind velocity value, we specify that can be set in the national annex. and that's a continuation of current practice. But what we then go on to say is that the effects of climate change should be taken into account, and that can be done by multiplying that value by a scaling factor or factor of change greater than or equal to 1. And we state that minimum values of that scaling factor can be set in the national annex. And then what we go on to say beyond that is that if on a project-specific basis, there is a desire to go beyond those minimum requirements that can be contained within a national annex, if there's a desire to go beyond that, then that can be done, and that might be in line with the requirements of a relevant authority, or it might just be agreed on a project-specific basis between relevant parties. But I think the really key thing to emphasize, to sort of highlight here, is this concept of a factor of change or scaling factor being introduced into the Eurocode, and that explicit statement that the effects of climate change should be taken into account. That is the text that we have, draft text we have in relation to wind. For thermal actions, obviously it doesn't work to have a scaling factor that you multiply by. You need to use a delta, an addition, or subtraction. So here, the equivalent text within EN 1991-15 draft has that delta TCC term rather than a scaling factor. So some quick reflections on this. What we see those factor of change, or the delta for temperature, very much as a hook, if you like. It is a provision that is included or will be included within the Eurocodes that enables climate change to be taken into account. The development, though, of those factors, we recognize is not straightforward. This is not something which has been developed without consideration. And there's been obviously work done in this area, and I've just on screen highlighted a few areas of work. Some papers, some work, this work from Italy, undertaken by a team from the University of Pisa. I know that they've also been doing work with JRC, and there's a very close proximity across to what we're doing within TC250. I think what is noteworthy when you look across to the plots on the right is that, in this case, looking at snow loads, those factors of change that are being developed, obviously identify, say in the case of snow, that values may go up or they may go down. Obviously, when you're designing a structure, you need to consider throughout its life. So you need to consider the early life. So if the change is a downward well into the future, you still need to consider the current position in relation to the initial life. But what we haven't done, and I think this is really important to share with you, what we haven't done is we haven't defined what that scaling factor should look like, how it should be specified. Our expectation is that it could be that might be adopted by some countries using a simple cautious factor. It may well be that countries will want to develop some kind of map. It may well be that countries need to think about whether there's an effective asset life, because there are some structures designed to the Eurocodes that have a relatively short asset life. There are others that have a very extended asset life of 100+ years. So how should the asset life be taken into account? And so really, to conclude, what we have sought to do within the Eurocodes is to provide that hook, to provide that expectation that climate change will be taken into account. The derivation, the determination of those scaling factors will be a matter that will be handled at a national level for inclusion within national annexes. And we are very, very hopeful that the team working on Mandate 526 and more broadly will be able to provide support in relation to guidance on that national annex development, and that will be highly valued, I know, by the broader TC250 family. And with that, John, that concludes the presentation, and thank you very much for the invitation today.
Steve, thank you. You're very welcome. That was some excellent work on bringing things together from a standards point of view and recognizing we've got standards writers, climate and weather experts and standards users on this workshop. It sets the scene really well. What we will be doing now is that we have 2 separate sessions with panelists. We have 6 panelists, 2 from weather climate science backgrounds, 2 from a standards user and 2 from a standards writer point of view. We've got Carlo Buontempo, Guido Riana, beg your pardon, Arthur Pinto, Michael Faber, Antonio Bagueno, and Rob Wheatley on the panel. And the panel discussion will be facilitated by Dr. Bulent Imam from the University of Surrey, good colleague of mine in the UK, and Dr. Efren Feliu from Technalia in Spain. And we've been working together at Technalia and myself on standards issues as well for Copernicus. And what we are going to do now is Guido Riana is going to set a pitch for the panelists, who will then respond to the pitch from Guido, and the facilitators will ask questions. And if there are time at the end of this will go on till about 11 o'clock UK time, 11 o'clock European time, 10 o'clock UK time. It'll go on to about for another sort of 35 minutes when we can have a short break. But we'll go through those questions, we'll get the panel's views, and we'll be logging this as well. And then if there's any questions in time that come in through the chat to the CIRMA name in the chat system, we will see if we have time to answer some of them. If there are many, we will select 1 or 2. So over to Guido. Thank you, Guido.
Okay. Thank you, John. Good morning to everyone. I'm Guido Riana and I work for Fondazione CMCC, a Euro-Mediterranean Center on Climate Change. Today, in this brief presentation, I'd like to share with you some insights about data information, about how to facilitate the communication between climate experts and experts in construction sectors, namely standard writers and standard users, in order to permit the prioritization of the action to be taken. As seen before, in the new European Strategy on Adaptation to Climate Change, the role and relevance of the standardization for the construction sector is highly stressed. And so it is important to pay attention to this one, to have a new generation of climate-proof buildings and infrastructure, while the benefits associated to the improvement or the update of the current regulation appear already clear at national and continental scale. Okay, but for the adaptation of the standard in the construction sector, as seen before, probably the easiest starting point is that of considering the first part of the Eurocode and the weather forcing included in it. Specifically, we consider, for example, the thermal action, where the maximum and minimum shade air temperature with the annual probability of being exceeded of 0.02 is assumed as reference for the reference height of 2 meters, or snow loading, where the reference variables is snow load on the ground, again with an annual probability of exceedance of 0.02, or wind actions, where we consider the 10 minutes wind velocity with an annual risk again to be exceeded of 0.02, but at a reference height of 10 meters. However, as a climate expert, as an expert in the construction sector, you are really aware about how, for the 3 weather forcing, the availability of data set at national and continental scale for this one, it is very greatly vary varies according to the time of interest, according to the time span, and so on. And in this perspective, it is important to take into account also the difficulties, for example, in retrieving observation or assessment at the proper spatial and temporal scale. So for this reason, for example, the assessment of weather duration action entrusted in national analysis are in some cases often stuck at 90s. So with rare exceptions. Now, the first issues that we have to face with is probably the availability of dataset at national and continental scale to have easily available and hopefully free of charge dataset. As reported in their website, the climate data store included in Copernicus Climate Change Service represents a unique opportunity for a one-stop shop for climate information. It includes several datasets for historic, current, and future time spans, where not only raw and correct data series are available, but also synthetic climate indicators for tailored sectoral needs, and also application for non-expert in managing climate information. Of course, in these days, during the workshop, Carlo Bontempo and Chiara Cagnazzo, working for the service, could provide much more details about the rationale and the service itself. So, but what do we ask to this dataset, to this service? Okay, we need an assessment of ongoing changes. Okay, in a climate change perspective, how reliable are the datasets currently exploited by national analysis? When and where it should be updated? After, we need assessment of future changes for the design of new climate-proof structures, building and infrastructures. Finally, several datasets cover the entire Europe, and so it could be a good opportunity for an harmonization of a reference value in order to prevent, for example, cross-border inhomogeneities. To this aim, with the colleagues of JRC and Tecnalia, we prepared a sort of first catalog where the dataset for the historical, current period, and future period for the three variables, temperature, snow loads, and wind, are prepared. So it is available as supplementary material in the page of the workshop. It is aimed at providing some indication about the dataset currently available in CDS for the analysis for the adaptation of the standardization in construction sector. For each one, they are reported the spatial and temporal resolution, the spatial and temporal coverage, the link where you can find the data, and the variable, the specific variables that you can find also as description in the overview page. Okay, it should be important also to provide brief caveat insights about such dataset and the use of the catalog. Of course, the number of datasets hosted in the CDS increases week after week. So it is provided as a supplementary material. It is only a frame of a very transient condition, okay? But only to a first brief overview about the potentiality of the service. The good news is that for the three variables, for the current historic period and the future time span, data time series are available. Okay, of course, the number of datasets, the spatial and temporal resolution with which they are available greatly vary according to the time of the interest and variables of interest. In some cases, the variables hosted in CDS do not properly fit the requirement of the standards. For example, the 10 minutes wind speed required for the computation of wind action cannot properly returned by the current generation of the atmospheric models hosted in CDS. On the other side, for other variables, they have been returned by the models, but currently are not hosted on CDS. For example, no variables as returned by regional climate model included in Eurocodec initiative, providing regional modeling over Europe, are currently not hosted in CDS, but are available, for example, on ESGF node. So finally, the reported information as a supplementary material only refer to the time series raw or corrected, but in some cases as dataset or application are available climatic indicators providing synthetic and brief indication about ongoing and future changes expected in for some indicators of interest also for construction sectors. After this very brief introduction, I'd like to move to the key question for the first part of the discussion. Which climate information should have priority for the construction sector? We got where, of course, both sides, construction sector and the climate expert. Why? Because we have to take into account several aspects. For example, for the construction sectors, which parameters are more relevant for the users of the Eurocode, which are, according to their expertise, the weather action requiring most urgently an update with respect to the current reference, or for which ongoing and future significant trends can be detected more clearly at country or continental level. For the point of view of climate experts, it is important in the selection of priorities to take into account challenges for their adoption, for example, available spatial and temporal resolution of the data, how to handle the uncertainty that is an issue that has been suggested, considered also in the previous talk, when we consider the adoption of a multiple climate simulation. Okay, we are really aware that it is a very long process, but at the moment we have to focus on the next step to be taken. Thank you.
Thank you, Guido. I now hand over to Dr. Bülent Imam and Dr. Efren Feliu to take this to our panel. Bülent, over to you. Thank you.
Thank you very much, John, and good morning, ladies and gentlemen. So I will remind the panelists once more for this speech. So we have obviously Guido Riana, who has presented the pitch. We have Carlo Buontempo from the European Center for Medium Range Weather Forecast, and they both are coming from the climate science and data point of view. We have Arthur Pinto from the Joint Research Center from the European Commission, and Professor Michael Faber from Aalborg University, who are coming from the standards writers point of view. And last but not least, we have Rob Whitley from Atkins Global in the UK, and Ralph Holst from BAST in Germany, who are coming from the end users of standards point of view. So as Guido said, we are looking actually at understanding the the opinions and the needs of people coming from different perspectives. So I would perhaps like to start maybe from Carlo Buontempo from the climate science point of view. So which climate information should have priority for the construction sector from your point of view, Carlo?
Thank you, Bülent, and thank you to all the organizer for having me here on this panel. Well, I guess the answer to your question from my point of view is, well, first of all, good quality recent data. So I think there was one information that was mentioned in one of the speeches this morning, and it's the fact that in many cases the standards still refer to 1960, 1990 baseline, which is clearly out of date. So we recently launched with the World Meteorological Organization the new climate baseline that is now 1990. 2020. So there is not even an overlap between the two time windows. So first, for me, this is the most important element and underpins a general change that I think we should consider for building standards. And is the change towards a climate that is no longer stationary, it's changing and does require information that is also dynamically generated. So having most recent climatology and to account for this trend. The second element is having a reasonable and we can put a lot of caveats and inverted comma on that reasonable, but a reasonable estimate on the expected changes for some of those variables. So I think what Steve was presenting with the approach of the Eurocode, with a sort of fudge factor to account for that, is a way of accounting for these possible changes. I guess my point is that given the uncertainty that we also heard from Andreas, these factors need to be themselves changing over time. So once more, I think is a systemic change the one we are facing, from a set of standards that we can consider done and dusted once and for all in many respects, to a new approach to climate risk, where the underpinning hazard actually is dynamically defined on the basis of the best available evidence at that time. So it can be updated every 10 years, updated every 5 years, but it needs to be updated because we know that the information as such is not stationary and is changing over time.
Okay, thank you very much, Carlo. So I would just like to remind the attendees as well that you can post your questions you have on the panelists through the CIRMA chat box option, and we will be able to, if time permitting, to go through some of the questions through there. Perhaps it would be interesting to change the perspective and hear the opinion from the writers of the standards as well. So maybe we can start with Arthur from the Joint Research Center. So Arthur, your opinion, please.
Yeah, thank you, Eamon, for the invitation. Good morning, everyone. Good morning, everyone. Yes, I suppose that we are all a little bit converging on a lot of things. The first one is that there is a problem, and this problem is accepted or is recognized by everyone, and this is a good thing already. The problem now is to get together and how to resolve it, and there are two things to be done. One of them is clearly try to bend the curve, I mean, to act in order to slow down and put down these projections, which are alarming, I would say. The second one is to start adapting, and this is the point, and we all agree on that. This is good. Let us see how to start adapting. This convergence, this facilitating the communication between the climatologists, the data on climate, and the data that you need for standards is crucial. I mean, is there that we have to put some rules? Is that we have to learn more how to get this data in a way that can be considered in the standardization process. This is one thing. But one thing is existing data. The other thing is the projection, and the projection is quite challenging. You see how it can go up, how it can go down, and it depends not only on what has been done, but how the measures which will be taking will slow down or will bend the curve. This is the problem. Uncertainty is there. When we design is a trade between investment, is always a trade between investment and risk. Okay, and we have to put it on table in that way. The solution is to go to a rolling adaptation, and everybody is talking about that, and this is very good, but pay attention because rolling adaptation needs something more in order to put the next generation know about that rolling adaptation. I would say that the premise is already there. Steve talked about, we have good practice and experience. These national adaptation parameters could be even in this climate change, having the climate change parameters, and these climate change parameters could be rolling, this rolling adaptation will be there. I mean, but there should be an effort, in my opinion, in the standards to identify which are the parts and parameters that are climate change depending. They will be subjected to rolling adaptation, and that's all for now. But there is one point. If you do this rolling adaptation, we have to take note of it and register it. And my suggestion is that we should go further and start speeding up these logbooks, these digital logbooks for buildings, and we have to have them also for the climate change to register this adaptation, this rolling adaptation. Yeah, and from the point of view of acting in the part of bending the curve, we have also, in terms of structural standardization and structural design, I would say, to think about how to bend the curve ourselves, to increase durability, to design for the construction, to design for adaptation, and being smart adaptation. I mean, designing for adaptation. Is it easy to increase strengths if needed in the future, for example? And I leave it here. Thank you.
Thank you, Arthur. Some very interesting and strong messages there. I'd like to pass to Michael, perhaps Michael Faber. So Michael, where do you see the highest priorities? Are there any specific, perhaps, weather variables that require most attention? Where do you see most of the challenges lying?
Well, thank you. I I really think it was interesting to see what has been done so far. But I also have to note that I think a step backwards might be a good thing to take, especially now when we are talking about what is it that is relevant to consider, what is it that we need to address. I would say that should have come out of a overview of the risk portfolio which we are addressing. So we need more clearly not to identify these three named climate actions. They were repeated a couple of times here. I see many more climate change related effects on our infrastructure than those which are mentioned, and they cannot be scaled up by a factor. It's a little more involving than that. You can imagine that we have precipitation events which will turn soft soil into a more hazardous substance with respect to earthquakes, for instance. Things like that we need to account for. We need to factor in the effect of increased and changed flood patterns. We need to look at coastal erosion. We need to look at storm surges. We need the full spectrum. But I don't think we can identify this today. But I think this simply requires a very systematic look at which are all the assumptions which we have applied for the design of structures in the past, because we need to deal with the existing infrastructure. Which are the assumptions underlying the codes as they look today? And then we need to look into the climate projections. And talking about climate projections, we also need to identify the system that we are looking at. Are we looking at individual projects? I don't think so. When we are talking about resilience, we are looking at systems, and we are looking at the full spectrum of the integrity management of infrastructure throughout their service life and beyond in reality. So we need, from the climate models, we need different scenarios. There is not only one model, as we have also seen originating from the ICPP. We need to deal with several possible scenarios, and we need to identify robust options for designing and managing the infrastructure. So we need the let's say the spatial variability accounted for, and in order to understand the dependencies in our infrastructure systems. And as I indicated, we need also the possible different scenarios originating from, let's say, from the competing models of how temperature rise is going to develop in the future. So it's quite involving, but I think it would also be a good time to catch up on, let's say, a science data-based modeling of the environmental loads in general in the Eurocode. So it's not an add-on. I think it could be a new basis for environmental load representations in the Eurocodes. Yeah.
Thank you, Michael, for a very holistic opinion there. You are right, there are a lot of challenges ahead, but this is a very good starting point, actually. We need to start from somewhere, and I think this will follow on quite nicely from this workshop onwards, and the work that is done on a European level and on our team as well. It is very important to hear opinions from the end users of standards as well, because the standards are written for the use from these people. So perhaps if we can start with Rob from Atkins. Rob, it is very important to hear your opinion as well.
Thank you, and thank you everyone for inviting me to this this conference. It's been really interesting to hear the discussions that have been developing, and yes, we definitely need to see how the standards going to, or the climate data is going to shift in the next century as climate change takes effect. But just thinking of the results, I'm thinking more along the lines of what Michael was saying. Out of the design parameters that I need to consider, I think the effects of precipitation, flooding, water and sea level effects are probably the main and most impactful level of information I need in designing my transportation infrastructure, and my expertise is in bridge engineering. So other data is important, particularly say on long span bridges where wind data becomes really essential. But I think there's far more impact across our existing infrastructure from the effects of flooding, and that is an area that I don't see covered at all at the moment. It is then down to national bodies to determine what the flood effects are required. Just also, I think we need to consider how the construction stage is an important part of this equation. So of the problems, the projects I've been involved with, major projects, new design standards, but 5 out of 7 of the last recent projects that I've worked on have had an impact on site of flood and rain, impacting the construction works with various degrees of impact on the overall construction. So it's managing that managing and understanding those issues from a temporary works condition, I also think is quite important and quite a lot harder, because they're only there for a couple of years, but they don't typically have a huge amount of sophistication to put into flood models or time to develop those flood models. So they have to have developed pragmatic rules to work on site in that duration of construction to protect the works and protect workers. So those are my thoughts. Thank you.
Thank you very much, Rob. And over to you, Ralph.
Yeah, also thank you very much to invite me to this workshop, and I fully agree to the topics just mentioned, but I will highlight some ideas or topics we think. We are dealing on the one side with existing structures, and on the other side we have to renew the structures, and then we have new structures. Therefore, we have to see different points. For the existing structure, we need reliable data. How will be the impact side changing? Not now, but also for the future. It's just mentioned also from Carlo. There I see we have good information from German Weather Forecast Service, but also from the other countries. Now we have to see how we bring this into the standards itself. But on the other side, we just also mentioned the resistance side of the structures itself, and also Arthur mentioned the design, the robustness of our structures, and the robustness of our network must keep into mind, because it's this topic, climate change adaptation, is a very huge topic, and the impact is one side, but our infrastructure must be more resilient. We must think about new materials with lower emission of CO2 and something like this. Maybe this must not be focused on this workshop, but the impact side is one side, but there are several screws we can deal with and we have to deal with. And for the existing structures, and to react very fast, we can bring this new impacts into the standards and see how we can deal with this.
Thank you very much, Ralph, and thanks to all the panelists for their interesting comments and thoughts. I think we have some time to get some questions from the audience, so I'd like to hand perhaps to my co-facilitator, Efren, to see if we can take into account any of the questions asked from the participants.
Yes, addressing the first questions. The first question about which variables are more relevant. Well, from the attendees, there is a specific hint about rainfall and flooding, which has been also addressed by the panelists, and perhaps could be good elaborating a bit further why the variables related to snow load, wind and thermal variables have been addressed, and what is happening with rainfall and flooding. There is also a specific question about the integration of climate adaptation in the EPBD, the energy performance of buildings, and which is not exactly the same as climate proofing infrastructures, which has been present in most of your interventions. There is also a specific question about the update of data and therefore ensuring the use of latest available information, which has been also mentioned by Carlo, and perhaps a bit more of elaboration in that respect could be worth. And I'm reading the last question, which is addressing this challenge of not only climate proofing new design, but also how to integrate the climate adaptation into existing infrastructure assets, and therefore in other elements like the maintenance, etc. So summarizing, rainfall and flooding, other sectors like EPBD and buildings, updates of data and application not only in new design but also in existing infrastructure assets. That could be a summary of the questions.
Okay, thanks, Efren. I don't know if we have time to go through the panelists and hear their opinions on this. So if any panelists would like to say a few comments, if we have time, John.
I think if we can run for just 5 minutes on this, Bulent, that'd be good, and then we can have a break until 10 past.
Okay.
Thank you.
Okay, are any panelists wanting to say perhaps a few words about the themes or the questions that were posed by the participants?
I wouldn't mind intervening if that's okay.
Please, Carlo, yes.
Yeah. Well, it's a bit of an answer to the question on the up-to-date data that Efren mentioned, but it's also partly a reply to what Michael was mentioning in his intervention, because I mean, maybe I went a bit too fast in my initial intervention, but the point is that we do have that data. So the model that the model of the past, or the reanalysis that we have on the climate data store. I'm talking about the climate data store because it's the program I know best. But in general, the information on the climate side and the climate perils is quite good for the past and for the future. So we do take into consideration all the sub-elements of the climate system and their interplay. So it's not generated out of a magic hat. So all these elements of the coastal element, of the atmosphere, of the land surface, and so on, are considered together. And we want to use those to inform the approach for adaptation. And in a sense, some of the question we had, and also the question on the update, well, you know, the most honest answer to the first question, what is largely up to you, which parameter you want, because we can generate all the parameter you like. And so we heard from Guido that maybe the 10 minutes wind is not there. Well, these are requirements that we can respond to. So I guess it's really that change of mentality that we need to, as a society, go through, whereby what is missing from the climate modeling side can actually be generated. So it's not just climate science sitting on a shelf, but is a service for the community that we are trying to build.
Thank you, Carlo. Arthur, you have your raised hand. Would you like to say a few words?
Yeah, the question, thank you. The questions are many, but I suppose that let me put something forward. I mean, I agree with Faber that saying that here you have a systems, element and systems approach, and I suppose that they are treated differently. Here you are talking about standards for the built environment, not talking about elements, essentially. In this, at least we think about it like this way, but there is something which is urban planning and urban risk, etc., which is perhaps to be considered also. And this comes out with the issues of flooding, etc. Is not anymore at the level of the element, but is the system, as Faber was putting on the table, and the colleagues also. And there, perhaps we are missing something. I mean, in the systems, in the urban side, is not the element, is more the system, is more the. We have to look at it. Okay, thank you.
Michael, I think you raised your hand at some point also. Yeah, please.
I tried to. Thank you. I just want to make myself even more clear. I'm not sure I did that. So what we need to address is that there are different scenarios for continued CO2 emissions, right? For a given scenario with respect to CO2 emissions, there is a relatively broad range of variability on how this will affect what we now are talking about in terms of environmental actions, right? So in order to be able to make decisions towards efficient decisions towards and robust decisions towards a resilient infrastructure in the future, we need to account for all of these different possible scenarios of CO2 emissions, and conditional on the individual ones, we need to understand the variability of the climate actions within, so to say, and design and major decisions on how to ensure resilience for the future. They have to be robust in the sense that if we choose to optimize a design or a code for that matter, relative to a given scenario of CO2 emissions, then we need to factor the possible disbenefits of doing so in case one of the other CO2 emission scenarios actually are realized, different from the one we optimized based on, right? In this sense, we need to ensure that our decisions are robust with respect to incorrect system assumptions, if you like it like this. This is what we need. And therefore, a code format in the future optimally should include, let's say, a weighing. It should include the different scenarios to consider. And here I'm talking about CO2 emission scenarios. And for those selected, there should be a corresponding, let's say, translation of what type of climatic actions are to be expected in those scenarios. So it's not, there's not one model, and this is what we need to deal with.
I'd like to jump in here now and just ask that we thank the panelists at this stage, because we've had some really good points coming over. Thank you, Bulent, and thank you, Efren, for facilitating this. I do see a couple of hands up, and sorry about that, but I think we need to move into a break and start again at 10 past, when we'll have a similar session, which will be a pitch by Sylvia. Will give a pitch, and then we'll have the same panelists responding to another set of questions. There is also the facility to log points in the chat facility rather than debate them, because we really are tight for time today. But thank you. We'll come back and have Sylvia Demova give a pitch for us, and then we'll move on to the second panel discussion. So if we come back by 10 past 11, 10 past 10 UK time. Thank you, Bulent. Thank you, panelists, for the first time, and thank you, Efren. And thank you, Guido, as well, for the pitch. I can welcome Sylvia Demova, who's from the Joint Research Centre at the European Commission, who's going to give a short presentation and another pitch to a panel. Sylvia, over to you. Thank you.
Thank you very much. George, do you see my shared screen? John, do you see my my screen?
I think I pressed the wrong button.
So
change my view. No, I've got you. I haven't got a shared screen yet.
No, strange. Let me retry. I first share the screen. No, it's not this one. Wait. Share screen. Just 1 second, please, because the window I had to share has been closed. Okay, just one second.
That's right. That's fine.
Okay, I turn this and I can see again my PowerPoint screen, which is very one more. Yes, now it is found and I put it in the slideshow mode. Do you see now the screen?
I see something, but you seem to have the presenter view rather than the slideshow view.
No, I'm in the slideshow view.
And I can see the next slide, and I can see black boxes where you have the list of people at the side. So maybe you shared your current desktop rather than the PowerPoint.
Okay. Really. Okay, stop share. And I have everything on my desktop, and it's really.
I wonder if Sergio can help.
Let's see. It says that I'm screen sharing.
We can see that, yes. With
Yes,
it's gone completely blank now. It's shared, but it's completely blank. Maybe if
can you please by yourself share the presentation?
See if I can find the presentation for you and work this through. Just bear with me a second.
Because I see perfectly my slide presentation.
I think I have the presentation, John. Maybe I can show my screen.
Please do. Yeah, I was almost there myself, but yes, please do. Apologies for this, everybody. This is,
yes, particularly from my side, but it's very strange. Okay, thank you very much.
Great
yes,
stuff.
yes, thank you very much. So, ladies and gentlemen, it is really my big pleasure to present you very briefly some insights on the use of climatic data in design with the Eurocodes, and in this way to make an introduction to the next question. Please, next slide. Next slide. Okay, why it's me making this presentation? It's me because I'm from the GRC, and we have a scientific network on adaptation of structural design to climate change. This network has been created 6 years ago in the frame of administrative arrangements between DG GROW and the GRC. And we are happy to have wonderful experts in our network. We have the chairman of basic subcommittees of CEN TC 250 and project teams on climatic actions, as has been already mentioned by Steve. We have experts on climatology and meteorology, and for example, Guido Riana, who posed the first question, is member of our network. We have many experts on structural design and on economic assessments. We have participants from DG Klima, from DG GROW, and of course from the GRC. And not on the last place, we have representatives from the CENELEC Adaptation to Climate Change Coordination Group, who are organizers of today's workshop. Thank you very much for the good collaboration and for the invitation. Next slide, please. So the main goal of our network is the update and harmonization of the European design maps for climatic actions, taking into account the changing climate. And we are performing pilot projects on definition of design maps in changing climate. This means taking into account climate projections for snow load accomplished, and Steve also show you some information on that. Thank you, Steve. On the annual minimum and maximum temperatures also accomplished, and a forthcoming pilot study on the basic wind velocity is quite a big challenge, sincerely thought, but we will do our best. And currently we are dealing with assessment of the climate change induced corrosion of built environment, which might become a very important issue in our future, having in mind the costs for combating the corrosion. Next slide, please. And here you see some of our studies on the snow load, on thermal design, on corrosion, which are published as open source information. You can find them very easy also on the Eurocodes website. Next slide, please. And all these studies were performed, and they shown that there is a need of design maps for climatic actions. Why? Because the users of the Eurocodes apply the maps for climatic actions which are specified in the national annexes. Also, the recent GRC report on the state of harmonized use of the Eurocodes concludes that The national maps for snow load, wind, and temperature present dissimilar layouts and reveal discontinuities and countries' borderlines. Thus, it's difficult to harmonize the use of the Eurocodes. Also, very important point is that development of maps for climatic actions for the Eurocodes is not planned neither under the mandate of DG GROW for development of the second generation of the Eurocodes, nor under the mandate of DG Klima for revision of standards for infrastructure. Next slide, please. Thus, there is a very strong need for European design maps for climatic actions, and the development of such European maps will help national competent authorities to redraft their national ones in a harmonized way by using the best available knowledge, and here is the place to say also, and the best available data. Also, they will contribute to the reduction of inconsistencies at borders between neighboring countries, and these maps can be published in informative annexes to the respective Eurocodes part of the second generation, as it is currently the case with the European snow map, which is published in annex to the respective Eurocode part. Next slide, please. So we have methodologies available already for snow and thermal loading on structures. Of course, as all the speakers before me stressed, there is considerable uncertainty in estimating climatic loading from climate change projections. This was the reason for the recommendation of the project team on climate change for the second generation of the Eurocodes for rolling adaptation by updating often. This is specified by them as 10-15 years, the maps basing on observed data. However, climate change projections can be used for predicting future trends in loading and other important effects, for example, corrosion. And what is important, what came from the presentation of the chairman of TC 250 is that country-specific choices of the magnitude of the climate impacts will be most probably allowed in the second generation of the Eurocodes for countries aiming stronger climate resilience, and these choices may be based on the predicted future trends in loading. Next time, please. The previous. Yes, and now is the time to pose the quiz, key question. How should the information on the design climatic loading, I don't talk about raw data, about design climatic loading, become available in order to be used and to act by the standards users? So which could be the location? Climate Adapt platform. It will be presented tomorrow by Hans-Martin Fussell. Climate Data Store in Copernicus Climate Change Service, or in dedicated platform for the Eurocodes, or what would you propose? Which could be the format of the data to provide values or increments, anomalies between future and present data? Also, which should be the computational format of data, NetCDF format, which is good format, LAP, ArcGIS, or Excel format, accessibility of the data, PDF maps in the national annexes like right now, or interactive web platform where data is constantly updated considering the signal given by climate change, or in case could be presented on maps, or a possibility to search for geolocation. What could be the actuality? This means time span of update, or also we can talk how about issuing system certificate for the date of downloading data, and so on and so on. Of course, what could be the training needs, and other issues. Now is the moment to dream about what the future should be. Next slide, please. And it's really not easy being green, but the floor is yours to say how do you see the answers to the questions. Ladies and gentlemen, floor is yours, and I thank you for your attention.
Thank you, Sylvia. Thank you very much indeed. I recall a slide earlier on that Abdebuk put up that showed complexity of the organizations involved. I think everybody's appreciating that not just the organizations involved are complex, but the whole concept of bringing climate information to standards is very complex, because yeah, when do you take the data, how valid is it, what format is it in? All these questions need to be answered. And of course, what we're trying to do in the mandate 526 project is look at a technical report that might be able to bring together some of these thoughts as an outcome of this particular bit of work, and this workshop helps. I'd like to hand over now to Efrem from Technalia, who will be fielding the questions and facilitating discussion again with the panelists. And again, if you have, as a participant, any questions or comments, please put them into the chat under the CERMA address rather than everyone. To CERMA, then Bulent will be filtering them and passing them to Efrem to bring to the panel. We have until 12:20 UK your time, 11:20 UK time for this session. So I hand over now to Efrem. Thanks again, Sylvia.
Thank you very much, John and Sylvia. Well, this is the second round of the panel discussion, bringing in the insights from Sylvia's presentation. But it's a kind of follow-up of the previous discussion, which, well, I thought it was going to be too much time for the same panel, but it was clear that there is still room for a lot of discussions that we will try to address now. The intention now would be having two rounds of the panel addressing. I will be grouping some of the key questions that Sylvia presented and following up in some of the previous discussions. Two rounds with interventions from the 6 panelists. So Guido, Carlo, Arthur, Michael, Rob, and Ralph, that, as we saw, are bringing in perspective from different angles. So standards writers, climate science and data provision or providers, as well as end users of the standards and the climate data, as a matter of fact. Okay, for starting the first round, I would like to bring in elements that you already addressed in the first panel in relation to the systemic approach. So going beyond the element itself and addressing challenges related to urban planning or spatial development. The links with scenarios, emissions, or emission scenarios, sorry, and therefore the link with mitigation itself, but not only with mitigation, but with the broad range or spread of results that climate projections could give you. And therefore, I would like you elaborate on this issue of the uncertainty, taking into account that spread of the different areas, the different models, and how should that be addressed when implementing or making use of the standards and norms if the selection of those projections, and therefore a bit more optimistic or pessimistic, should be something discretional, or if it should be something already framed and oriented through the standards and norms itself. And in relation also to the uncertainty, this actuality that Silvia was mentioning, or Carlo in the first intervention was referring to dynamic factoring, taking into account that climate information is updated. This update should be fixed at European level with specific dates according to IPCC updates, for example, or to Codex updates, or how to address these periodic updates from the point of view of applying the norms. And therefore, if a kind of certification, as Silvia was suggesting, should be also requested in relation to the use of most recent or most updated climate data. So summarizing this first round, uncertainty and spread, discretionary selection or not, and updates, compulsory updates, and in certain with certain certificates or not. So this could be the first round. I don't know if you want to follow that same order, Guido, for example, in first turn.
Okay. Thank you, Efren. Thank you for the presentation by Silvia. Okay, they are very challenging points issued by you. I start from the second one. Okay, the updates. Of course, I agree with Carlo and the other speakers that it is no time again to have a steady state tool. We need a sort of transient update. Okay, and so we have we cannot risk to not have update in the maps for 30 years. Okay, because climate change increase and variation are more clear purely at the continental national scale, and so we have to change our mind, moving to a sort of a platform, institutional platform, where the update should be located clearly, easily available to all the potential users, standard writers and standard users. So I think that linking also to the first question by Silvia, it is important to move the rational using for the national annexes or for the weather parameters, where a new idea, new approach is needed. Okay, so in this perspective, also the update should be taken into account the increase and improvement, for example, in climate modeling. Next year, probably we can start regional modeling starting from the new generation of CNIP6 simulation. It is important when they will be available at regional scale, for example, as downscaling from Eurocodex, to use this information for the update of our knowledge. At the same time, as you know, the increase in our knowledge of the climatic system, and then the increasing potentiality of the computational system, for example, in terms of spatial and temporal resolution, should be taken into account. It is not easy, it is not clear to us, for example, which should be the best suitable time to expect variation improvement, but we have to take into account several aspects. For what concerns the second point, the first point, the uncertainty, okay, it is a very open question in the climate expert community, because as you know, for example, we have now from Eurocodex more than 20 climate simulation available for different representative concentration scenarios. So all the models differ for very different aspects, for the machine on which they have been carried out the simulation, for the physical parameterization and so on. It is not easy. There are in the literature several methods to select a subset, but they represent an open question for the climate expert communities. And so it is not possible, at least for me, to provide a sure answer to these questions. At the moment, we have a lot of knowledge about the future scenarios, for example, as provided by Eurocodex. We have, in my opinion, taken into account. There are some certificated peer-reviewed methods to select subset. We can also refer to this one, but we are taking into account that is not a definitive answer to your question. Okay.
Thank you, Guido. Carlo, would you like to elaborate a bit further on the issues already addressed by Guido in relation to this uncertainty spread of RCP models and well, discretionary selection, or,
Yes.
or what could be the way forward in the field of standards?
Okay, I'll take it. And I must admit I'm sort of allergic to uncertainty, because every time you have a discussion about climate projection, then there is a discussion about uncertainty, and it seems to be an unsurmountable issue. And there we are. A year ago, nobody was prepared for COVID, and COVID hit our life badly. So, I mean, we deal with uncertainty all the time. And actually, I would like to stress that climate projection in many respects are quite certain. If you look at the projection of exchange rate or economic GDP, well, they are much more uncertain than what any climate projection for temperature, for instance. So there is a lot of uncertainty in this climate projection that can be harvested. I mean, clearly there is uncertainty, there is no doubt. And that uncertainty will stay no matter what we do. So we may have 200 model runs, we may have higher resolution, better emission scenario, interactive carbon cycle, vegetation, what you want. But if anything, the uncertainty will probably go up rather than down. So this means that for me, we have to make two transitions. One transition is on the climate data provision side, and operationalize the production of the underpinning data, simulation and metadata and support. And we can go back to this aspect that I'm very passionate about. But the other side is to realize that this interface between climate data and society actually involves some elements that are not just science. So what I like of the presentation of the Eurocode was that it was a pragmatic solution. So there is a factor that we put in. And it's not perfect. We have to make a decision, but it works. So I think what we miss and what we need to go towards is a series of pragmatic solutions that can be defensible, because we won't be able to have a standard that takes into consideration 500 simulation, right? We have to have a pragmatic solution, and this needs to be reasonably defensible and needs to be updatable on a regular basis. So that's for me the connection between the uncertainty theme and the theme of the regular update and interaction, and whether they are mandated or whether they are left to other existing cycles such as the IPCC, the ESGF data set, Eurocodex, doesn't quite matter, provided there is that mechanism that revises the information and once more makes a pragmatic assessment and a new set of figures or references that can be put into standards. Thank you.
Thank you, Carlo. I do agree with that. Well, the term uncertainty has a lot of connotation, and as a matter of fact, we deal with it in other fields, as you were saying, other type of projections, and we are not as strict with coping uncertainty in the field of climate as in other fields. But well, we can talk about the spread, for example, which is representing also the challenge of which type of climate data or projections to use. That way forward with the factoring is perhaps a good way forward, but we have to make choices in sizing the factoring, taking into account the climate projections. And of course, as you were saying, it is quite important to take into account that this would have to be updated. Taking into account these elements from the standard writing point of view, so the spread, the choices we have to make in relation to certain factory and the updates, what would be your point of view, Arthur, for example?
Thank you. Yes, I would subscribe the comments of my previous colleagues, and I welcome this last slide of Sylvia, because there is something very concrete there, and I suppose that we should go ahead with it. Let me see. We come again with this actuality way of rolling it, and perhaps this is the key. I mean, I suppose that your question was a little bit on that. I mean, but before going to this, let me see that we are here, we are looking at it from a European perspective and CEN standards, etc. But I suppose that you should give it an international perspective. And this is, we know that even in terms of political terms, Europe is there and the decision is there, but United States came again back and is there with us, and we should look at it internationally. Even this effort or this initiative of data, and should look at international alliances, I would say, to connect to other initiatives in other places along these lines and to join forces. Coming back to this part of the actuality, this is a very, very, very difficult question, I would say. And yes, you say everybody's saying it is there. It is not a storm. It's not a wave. It's a tsunami. I mean, and we are there on that. But be careful, because you cannot. We know that it will be there and it will be there, but you cannot. This is a very, 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 very strong decision. I mean, when do we update these things? This is quite, from my point of view, I suppose that we should not exaggerate. I mean, we should not go yearly or something like that. I suppose that we should put it at the level of the present timing of updating standards. And if you look back a little bit, Eurocodes came out at the beginning of the century, I mean, under 2000, near 2000, and we are coming back with the second generation 20 years after. I mean, I suppose the maximum that you can do is 20 years. But you can divide it by 2 or something like that. You see, between 10 and 20 years, I suppose that it's there, this actuality. And this is the point to be decided. Another point is that be careful. Uncertainty is there. There are other factors and other events much more uncertain. Yes, but we should not put everything in the certainty, because it could be, we should always do the life cycle analysis. I mean, we should go on this way and try to reduce this uncertainty. I mean, this uncertainty comes out with a rolling period. I suppose that we should put them together. And as I was saying at the beginning, put together the digital logbooks for the buildings and infrastructure. We should have real knowledge about our infrastructure. I mean, if you don't do this global analysis, we have to have good data in the future. We don't have it today. What you know about our infrastructure is more or less the year of construction and nothing much more, okay, you see? And this is a difficulty. We should not give for the next generation the same state of the art, I would say. We should give much more information on things which are changing at a much faster pace. Thank you.
Thank you very much. And as a matter of fact, it's quite interesting bringing in how there are elements related to the life cycle of the infrastructures, to the system in which they are functioning, which makes more complex the decision, and therefore there are not only decisions about the climate data to use, but also how to interpret the overall functionality and therefore the climate proofing in that broader context. Anyhow, at a certain point, we will have to make choices about which climate data to use in order to apply the standards. Being like that, I would like to continue with that question to Michael from the standard writing perspective and the standard application perspective, how to make the choices, and should that be something standardized at European level? Should that be something discretionary in the application at national level? What would be the way forward in that respect?
Yeah, well, this is a pretty good question. I would say I would like to just go back to the comment I made earlier, that it's probably a really good idea to establish a risk inventory related to effects of climate change as a starting point. I mean, this is always what we do when we try to understand how a system is affected by something potentially new. So we go in, we identify which are the resilience characteristics and risk or reliability characteristics which could be affected for the portfolio of infrastructure systems that we are dealing with. And then this will guide us to understand which scenarios are affecting those performance characteristics in what ways, right? So we would be able to understand. Then as a next step, I would strongly suggest that a number of benchmarks are picked out from the portfolio of infrastructures and buildings, which are, let's say, under the wings of the Eurocode, the structural Eurocode system. And then we look at how, for these particular types of infrastructure systems and buildings, the different possible IPPC-related scenarios are having effects and how they are having effects. And thirdly, how can we improve their performance characteristics? So resilience, reliability, risk, performance characteristics. That will automatically point at which are the information that related to climate change and derivatives of climate change on environmental loads and load effects of changing environment. That will simply point to which are the critical information that we need to represent. You know, I did not like the discussion about the factors and being pragmatic. I think jumping to a factor modification of an existing code format is like jumping to the solution without having any clue why that is actually reasonable. It could be, and I can certainly see where the idea comes from, that for some particular effects of climate change, yes, some load characteristic value of a load can be modified by a factor. But we are probably more dealing with something like introducing new load cases, depending on the different scenarios and depending on the type of infrastructure system that we are dealing with. So we have all these different load cases in the Eurocode system, and probably it would be an idea to consider to extend that approach to account for the specifics of the different CO2 emission scenarios projected by the IPCC. Regarding, I think I agree with Pinto. Yes, we need an update of these things at reasonable time intervals. If we would do it every week, it would be a total disaster for every stakeholder involved. Every year, I think something similar. I might suggest something between 5 and 10 years, probably more like 5. I would say is a reasonable approach.
Thank you very much. let's see from the end users or the application of the Eurocodes, the standards and norms from Rob and Ralph. What is your impression about this discussion about the discretionary use of scenarios? Where should that be defined in order to apply Eurocodes, the updates, etc.? Your views, please, on these elements. Yeah. Rob, please.
Yeah, thank you, Efren. Yes, interesting that Carlo said it. He didn't like uncertainty. I'm quite, as a practitioner, I'm quite used to handling uncertainty. But the thing that I find important with the uncertainty is understanding what that variability represents. And so I find with an inherent lump figure, scaling factor, there's quite that can lead to having to design for scenarios that don't actually exist. And I was wondering whether it would be better, or you could better define the scaling factor. Maybe it could be defined in terms of return periods and maybe different interactive maps to mean that the scaling factor could be smaller, and that you're using different basic data to tackle the problem. In terms of discretion, I think clearly we've got the overarching principle set up by the Eurocodes, but we're talking about dealing with national annexes and national maps, nationally determined parameters. So I suspect that probably has to be set at a national level by the relevant authorities as to what they want to see in that. But having that wider information backed up across a broader network of European network or even an international network would give our own national authorities some legitimacy and backup with the data that they have. In terms of compulsory updates, that was a good question, and it creates some interesting side effects as well, in that when you bring in an update to a standard, there then becomes a discussion, particularly when a project is in the middle of a design or a construction period, as to which standard you're then going to apply and what is the cost impact of applying that standard. So I think, given the fast changing nature of the problem, we will need compulsory updates, and I think they need to be done very frequently, maybe more like 5 years rather than 10 years, just to keep abreast of the situation. Certainly in the next short-term period, up to 2050. After that, I'm hoping that the climate science has advanced even further, and the political issues have been tackled and resolved, we all hope, such that we then have a better idea of that uncertainty bandwidth will be coming down. But at the moment, while it's still all up in the air, I don't think we can afford to be very slow on updating figures, which we're finding, when the data is showing us things are changing quite rapidly. So that's my view.
Thank you very much. Quite interesting your point about NDPs as the scale where decisions should be made, or the choices about selecting scenarios, etc., should be made. But with that hint about backed up by European bodies or European data, or which is quite interesting, and I think that that is a crucial part of the discussion, balancing what is coming from Europe and what is based on that framework decided at national level. Okay, Ralph, would you like to intervene about these issues?
Yeah, thank you very much. I fully agree to the topics and the ideas just mentioned from the colleagues. I think also we need an update in certain times, but as Rob just said, it's not so easy when you have a contract and how to deal with the new information or the other information. But also we have to deal with scenarios because it's as a road user or road authority, you cannot design and calculate the bridge for every probability of occurrence and the highest level. I think we have to think about risk classes and to see what the part of network belongs to. In Germany, the A roads are the highest level, but the K roads are lower ones. But I will add some aspect about the kind or type of impact. We are discussing about temperature, we are discussing about wind, we are also discussing about rainfall. Wind and temperature belong to the area where I have maybe a bridge or something located. There I will have maybe a map or something like this with temperature with the highest level with probability of occurrence. But rain is a little bit difficult because rain, maybe I live near Cologne, there we have the River Rhine, and the problem for the River Rhine is not the rain in our area, it's the rain in the Alps, or in the Swiss Alps, in the France Alps, and that is from the point of an DOT road authority important that we also need, maybe not in the Eurocode, but we need flooding models and we need to have probability of occurrence, but because we cannot calculate with the most rainfall in the Alps, also with the most rainfall in the Eifel area or something like this, then it will be not useful. Then we will have bridges or something like this, not probability designed, and that's not easy to handle because rain is a special topic, and we have to keep in mind an idea how the road authorities can get reliable information, how they have to combine or to use this information. I think this is very important.
Thank you very much. You're also bringing in something quite interesting about the flooding models. We are now in the middle of the second cycle of the flooding directive application. And I understand that the climate challenge or how the climate challenge is sorted out in this second cycle is going to be important for example, application of certain codes and the return period approach, etc. So something to follow up in this discussion of standardizing or climate proofing design standards, the flooding directive and the second cycle. Okay, we have a bit more than 20 minutes left. I would like to make a second round with interventions from all of you and cross reactions if you want to, addressing other elements mentioned by Sylvia, which are quite important. One is the location of the data, the accessibility, the formats of that data, ideas about it. We have the CDS, we have EA with climate information quite soon. We can have a dedicated Eurocodes data portal. We can rely on national data portals. Well, impressions about that, how to make it available, how to make use of it, geoportals versus PDF maps, as Sylvia was suggesting, etc. And I think that also quite related to that is the training needs, the capacity building, who should be participating in the capacity building when advancing in the climate proofing of design standards and norms. My suggestion, as we have 20 minutes, and I would like to leave a bullet also bringing in Q&As from or questions from the attendees, I would suggest a very quick round with a pitch from each of you about these issues, accessibility, formats, and capacity building, to summarize, to say it somehow. And after that, we see questions from the attendees. So same order, I would suggest. Guido.
Okay, okay. Thank you. Again, I suppose that in the bridging the gap between climate experts and experts in construction sector could be a technological gap and scientific gap, and we'll try to bridge this gap. Okay, technological gaps should be also related to the managing climate data. As you know, in some cases are very cumbersome to managing climate data, and so the opportunity of using institutional website web platform could facilitate the uptake of such data. It is important that the users could rely on easily available data. Also, its NetCDF now can be managed by different codes and different types, but it is important that it should be in a form easily and readily available by the standard writers and users. And so I think that having an institutional platform where the data should be in a format that typical of those used by the standard users should be the best choice. Okay, NetCDF could prevent use in some cases. Furthermore, it is only, of course, also related to the needs of training in using, also about the assumption in using such data. As you know, in some cases cannot be enough using the raw data, but the data should be post-processed, for example, by using bias correction, bias suggesting procedures. The users should be aware about what means the using of further post-processing using data. And so it should be done by training, by tailored guidances that should support users, because at the moment these issues could prevent a reliable usage by of the standard, the adaptation, the missing of the adaptation, the standard.
Thank you, Carlo.
Thank you, Fran. Well, from my point of view, as I was mentioning in my first intervention, the big challenge we are facing is the operationalization of climate service or climate data provision. So that's the challenge, and it's a challenge in terms of interface to the user, and it's a challenge in terms of organization of the information. So for me, there are a number of key ingredients, one of which is to provide access to all data in an open and a transparent way. So all data meaning historical data, meaning near real-time data, and means a projection in a consistent way that is easy to access and to use. The second element is to have good documentation so that the data is understandable, is provided with quality information and so on. And this means then, being operational is also means having training, having documentation, having support for this data set. And there is this underpinning IT or information management challenge, because we are talking about huge data set. So, I mean, when we are talking about format, I think this is actually a quite marginal element. So if you have to manage tens of petabytes of data, you cannot do it in Excel or in something else. There are some binary format that you want to use, and so let's leave it to the expert how to best manage that. But then there is the aspect of usability. So we need to have interface between that system, whatever system we think is appropriate, and the users, because the user don't speak necessarily the language we use for the database, and we need to have a useful interface. And that interface needs to be traceable, meaning that anyone should be able to go back to the original data and back to the tools that have been used to extract, post-process, bias adjust, and so on and so forth. So for me, this is the challenge. Now, whoever does this job, I think, is in a good position of underpinning these standards. I mean, clearly, from my perspective, very biased perspective, I think we have done a good deal of a road in that direction with the climate change service. So we now have 76,000 users registered, and we deliver to them something close to 100 terabytes of data per day. So we have part of that infrastructure that we can use, and we will be delighted if people were to use it. But if someone else does the same job, for the standard point of view, doesn't actually matter.
Thank you, Carlo. Let's continue with these quick pitches about location usability, user needs, capacity building, etc. Arthur, please.
I'm sorry, could you repeat, because I lost the sound before.
Yes, don't worry. We were talking about the second type of questions addressed by Sylvia in relation to the location of the data, to the accessibility, to the formats, and to the capacity building in a broad sense.
Yeah, this is a point that perhaps I'm not the person to talk about. I mean, it's not my specialty, data analysis, or data curation. It's either there are experts on that. One point that I would like to perhaps to say is that the data that we need for the standardization is another level. I mean, the climate data is the speaker before was talking about. We have lots of data daily, etc. Yes, but the thing to be done, how we pass from this data to data relevance for standardization. This is the point there. And we have already some pilot projects on there, you know, the snow, the wind, ongoing, etc. These are pilot projects that we have to run again, and with other applications for other sectors. And this for me is very important, because you have to do this bridge between the climate data, crude as it is, to the data which is relevant for the standardization process. Another thing which is important, I would like to refer also, is about this platform, this data platform. It could be also used to serve as, I mean, to vehicle, to engage the citizen, to engage the stakeholders. I mean, you see, we are talking only about climate data and going to the standardization, serving the standardization, but I suppose that we should open a section there which is to engage the stakeholders, and by the end of the day, the citizen. I mean, this is perhaps I'm asking too much, but I suppose this is very important, because it's a combat, it's a war that we need to do all together, and engage the citizen, engage the citizens in this combat. Thank you.
Thank you very much. Michael, a pitch about this?
Yeah, very short. So what I would find tremendously valuable would be to establish these data and access to data on a totally open platform with some guidance on how to undertake different types of extracts of the data, exemplified by some particular assessments. So to illustrate what is possible using this open platform of data. You can find similar platforms under the United Nations, some of the working groups, you can find it also in the OECD. They have huge databases which are publicly open with examples on how to do certain types of manipulation of data using the databases. I think this is what we need. We need simply more people putting their energy and efforts and good ideas into harvesting knowledge and shaping the basis for decision making for the future under the uncertainty by which climate change are subject to.
Thank you very much, Rob.
Right. Yes. Thank you, Ifrin. The data that we talked about, the climate maps, and Steve Denton in his presentation kindly put up 3 PDF images of the maps. I really feel that we need to move on with that technology now. Graphical information systems are much more advanced and available. We have very advanced systems for things like environmental areas, environmental restraints and special considerations for Ramsar sites and other sites of special scientific interest. So why can't we have an interactive map for the climate data that then could be updated at an appropriate time, and we can drill down then into that map, because the map, you know, an A4 piece of paper to cover the whole of the UK is, you know, leads to some discussions, but it'd be quite easy to have a system that could drill down into a lot closer and smaller units. So I'd just like to see that information being readily available and updated frequently. Thank you.
Thank you very much. Last intervention about this issue from Ralph, please, and we'll go for the questions of attendees.
Yes, okay. Thank you to the ideas from the other side. I think it must be from the end user side, and normally we are bridge engineers, civil engineers, no IT experts, and no climate change experts or weather experts. We need data. We don't have to interpret. We have to see, is it useful for my area? The weather models are belonging normally to huge areas, and when I design a normal bridge of 50 or 100 meter length, it's a very small area, and therefore it must be clear what impact is I have dealing with, and when I have more background, then I can go to more information about for the normal bridge inspector, bridge calculator designer. It must be clear how to use it, and therefore, as Carlo mentioned, there must be an interface that it is clear how to use. That's important. About the format, I cannot say something special here.
No, but I think that you all have addressed important elements related to the processing the raw data, to make it operational through traceable interfaces, the need of support, and the overall usability. And well, in a framework of digitalization, geoportals, interactive maps, which I think that we cannot avoid, as Rob was mentioning. Thank you very much. We have about 10 minutes, and I would like to give the floor to Bolet to bring in reactions or questions from the audience, from the attendees, please.
Thanks, Efren. Yeah, there are 2 or 3 questions and some comments there. I mean, there's obviously the question about standardization of data formats, which, you know, we had some opinions here, but you know, one of the attendees was asking whether there has been any progress about the standardization of data formats, including the uncertainty, identifying the need actually that, you know, there are national annexes for individual countries, but EU-wide standard data formats would help with actually cross-member states working, especially on some infrastructure networks that are passing, you know, from state to state. It's not just you know, the opportunity for one country to do an analysis, but we need more of a cross-member state working. So I don't know if anyone wants to say anything on that, about whether there have been any progresses on deciding about, you know, the standardization of data formats for climate change and uncertainty. Carlo, yes, over to you, perhaps. You are probably the most suited out of everyone to say a few words about the progress in this area.
Well, on the standardization, there has been, I mean, I would think that on the climate side, we are ahead of the game in many respects. So for climate projection, the standards are quite well defined, and they have been in place for a number of years. There is always space for improvement, and we see the needs for this improvement. But again, I think there's been quite a bit of effort that has gone into the standardization across different data sources. So having observation or reanalysis data in the same format and with the same characteristic and metadata that you would find from a climate projection. So this is really useful, and a very significant effort has gone into these in the last few years, and in the characterization of the uncertainty, but in general of the metadata and attribute of this data set across the board. And this is required to do exactly what Arthur was asking for, so that tailoring for the specific audience, because on the one side there is the management of the information or the data, and on the other side there is the interface and the tailoring for the standard in this case.
Okay, thank you, Carlo. I think you muted yourself in the last few seconds, but
sorry.
I think we got your message in the end. Thank you. Arthur, yes, you want to add anything on that?
Yeah, okay. It's only to see that you have asked us to see, some concrete examples where this interface has been already put in practice. And I would suggest to go back and see the things that were mentioned by Steve and also by Sylvia, these pilot projects done on snow. I suppose this is the first examples where something came out and there was really interaction between climatologists, climate data, I would say, and data for the standardization. I suppose these works are pioneering, and now they have launched the part of wind loading. And I suppose I would ask Sylvia to put in the chat the link to these reports. I suppose it is already there. If not, Sylvia, please, could you do it? Because it is to make it available to everybody. But I suppose there are other examples, papers, etc., where this has been already done, this effort. That's all.
Thank you. Thank you, Arthur. And thank you, Carlo, for posting the web link to the, for the benefit of the attendees. There's this question about what we discussed earlier about the use of scaling factors. So does the concept of a scaling factor not continue to make the underlying assumption that climate is stationary? Surely any design loading must be related to the design life of the structure. So any comments on that from any of the attendees on the use of scaling factors for design?
Michael has his hand up.
Okay, Michael, yes, please. Sorry, apologies, I missed that.
No worries. Well, yes, to the extent I understand correctly, but now if I'm wrong, immediately please correct me, Imam. In the Eurocodes, traditionally we had reference periods of 50 years, but then I understand that due to pressures from here and there, we also got a reference period in for 1 year, but it's still an option to have 50 years. Is that correct?
I think so, yes. Yes.
Now, when we're looking at non-ergodic phenomena, like in question here, it really does not make much sense to try to envelope it in anything but 1 year reference periods. So we need desperately to understand the exposure conditions for the built environment as it progresses through its lifetime. So the information we need in terms of effects of climate change are with respect to the different scenarios as discussed before, but we need a thorough, let's say, a differentiation, a consistent differentiation between the model uncertainties and the statistical uncertainties, and let's say the inherent variability conditional on the assumed model basis. That is essentially what we need. And again, I think shooting directly to some amplification factors is really not the point in time where this is possible, as we do not know, as if I understand correctly, that you have not made the mapping, you have not made the risk inventory of how climate change effects are going to affect our infrastructures. And I'm talking about derived effects of temperature change, like melting of permafrost, increased precipitation, And you're looking at me, you're wondering where do we have permafrost, but in the Alps it is an issue, and it does affect the landslides. It's not only extreme variations in temperatures, but it's also let's say the variability over the individual years, which play a role for release of rockfalls and precipitation events, how they affect landslides and flood events, and so on. It's more than an amplification factor on wind pressure, and you cannot jump to this format without understanding the system. So I really hope that we will have an opportunity for this exercise, an add-on project where we could try to understand the system, the risks associated with climate change from a more holistic perspective, not just a shortcut to a multiplication factor.
Thank you, Michael. Yeah, that's I think a strong message to that we need a system of systems approach, you know, in anything we do in infrastructure. I mean, isolated decisions can have actually adverse effects in the end, unless we understand actually how a system.
And then at the same time, just like what we always do when we do code calibration, code design, you could call it, we go in with a couple of representative cases to see how different possible ways of handling a new uncertainty or a new load case or new phenomena affect what we do already. So we make these consequence assessments in order to understand how different schemes or different strategies to handling a situation might affect the outcome, the end result.
Thank you, Michael. There are a number of hands, but I will give the priority to John as our chair because I'm conscious a bit about time.
Thank you, brilliant. I'm really pleased to hear the discussion. It just keeps on going. It's really good, but we need to sort of wrap up things now for today, and I'll invite Abdibak to come back with some of the observations he's made during this morning's long session, which have been really good. Just one sort of comment, a couple of comments from me. One is that one of the areas in ISO 14090, which is the principles, requirements and guidelines for adaptation planning, seem to pick up some of the themes we've talked about just now. It's an overarching standard, it's not sort of sector specific, but one of the areas it talks about is, like Bülent just mentioned, a systemic approach to climate change adaptation, and there's the guidelines in the standard about using systems thinking for that. And a second consideration is about decision making, and decision making has a big part in that standard, and for making short asset life cycle decisions around short assets that have a short life cycle. Yes, decisions around assets that have a short life cycle are simpler than decisions about assets that have a long life cycle. So if we're designing something that's going to last a century or more, nuclear power stations, difficult in some ways with sea level rise. But for designing things like bridges with 120-year design life, that sort of thing, the complexity over the uncertainty, both on the hazard side and the consequence side, is something that needs more analysis than, say, if you're designing a building for a data center that might have a 20-year life. So there's proportionality in here somewhere. But these are things I thought were quite relevant in that last sort of discussion, looking at pragmatism and complexity and so on. But I'm in danger of taking things over. Ab, I'll pass over to you. But thank you very much, everybody.
Yeah. Hi, John. Thank you for that. Can I share my screen?
It's working, yes.
It's working already? Okay, yes. So it was a bit a challenge to, as the discussion is quite active, well, it is a challenge to capture the key elements. And Well, the two words that I would like to start with was bridging the gap from Guido Rihanna, and the word from Arthur Pinto, converging. I have the impression from this session that the awareness about the importance of using information about the future climate into the design and construction of infrastructures, that we are more and more converging towards the question how to do it, and it is not the question should we do it. I think that Andreas expressed quite clearly, or showed quite clearly, that the impacts of the climate change do affect especially the extremes. So that urges that. And another observation was from Andras, who has indicated that one of the priorities from the European Commission is to accelerate climate change adaptation, and mentioning the role of standards to that. But a key point today, I think, was the hook mentioned by Steve Denton, the hook that in the Eurocodes a scaling factor can be included as a pragmatic solution. He indicated that it should be in national annexes to be worked out, that way of approach. I will come back to that later. I would also like to come back to what Ralph Hoost indicated, that from the user's perspective, it's important to keep clear data, not data that he has to interpret himself, but that the data in the end available are clear. And what was for me also quite interesting was that Carlo indicated, and Guido added to that, that indeed already a broad range of data is available. There is massive information available about the future climate, and it is just the question of how to streamline that to the user side. In the discussion, I picked up several elements with regard to that idea of a scaling factor. One is, I think, that there was a broad consensus that such a factor should be dynamic. The climate itself is changing. We don't know what scenario for climate change it will follow. There are the uncertainties, and we should monitor what happens, and based on that, such a factor should be dynamic. Also strongly put forward, for instance, by Michael Faber, was the issue that we should consider also other aspects than the one taken into consideration in the present generation of Eurocodes. Flooding as an important issue, which relates to a much broader area than just the event itself. And the urgency also for frequent updates of the national determined parameters. So that's what one issue, I think, and Michael Faber urged, I think, towards a more fundamental approach than the use of scaling factors, investigating closely what are the impacts of the changing climates, what is the impact on infrastructures and risks, and what should be, what are the risks, the climate risks that should be dealt with, and how would it result in designing. My personal feeling, I'm not an expert from the construction sector, but I don't see necessarily that those are two conflicting approaches. I could see that the first one could be a pragmatic way for the first, for the short term, and on the other hand, for the long term, you look for the more fundamental approach, but that's not up to me. Overall, I think that within this workshop, from the three corners that we have at the table, there is consensus that the climate is changing and that there is an urgency to include the impacts of a changing climate into the ways of designing and constructing. That data are the data sets are to a large extent available, but that it is a key to come to operationalization of the information, that it comes available in a form that in the end the users of standards can really need it, use it. And for that, given that the information is complex, training and guidance will be of crucial importance. There are some observations from my side from the discussion. In total, I see conversion and also towards operationalization. How can we make the information and the insights available and usable?
Great, Ab. Thank you very much. So I need to thank everybody, participants, keynotes, facilitators, pitchers, and panelists for today. It's been quite an in-depth discussion at times, and like Ab, you were saying, you know, there's a lot of consensus as to ways forward, and the urgency, I think, is very important as well, as that's been recognised from UNFCCC, Paris Agreement level, right down to people in the street. The climate's changing rather rapidly. So I'll close this morning's session, or this afternoon session, because we just crept into the afternoon in some places, and say that we will see you again tomorrow at the same time, 9 o'clock CET, 8 o'clock GMT, and Jose will be chairing tomorrow's session, so I might not have to wear a tie. See you tomorrow.
Thank you very much. Bye-bye.
Thank you. Thank you.
All right, thank you very much.
See you. Goodbye.
Goodbye.
Thank you.
Goodbye.
Bye. Thank you.